Hello, everybody. I'm Chris Gladwin, the CEO of Ocient, and I'm thrilled to welcome you to another episode of Big Bytes with Ocient. This is the podcast where we dive into the fascinating world of data and explore how the analysis of massive data sets is transforming industries. Today, we've got an exciting conversation lined up for you. Think of it like peanut butter and jelly, modern hardware and software. They go hand in hand, and when they're designed together from the ground up, the results are game changing. To help us unpack this topic, I'm joined by two amazing guests. First up, Ace Stryker, Director of Market Development at Solidigm. And alongside him, we've got George Kondiles, Ocient's co-founder and chief architect. Great to have you both here. Solidigm recently announced a 122 terabyte PCI solid state drive, which is just incredible. To put that in perspective, if you had, let's say, a 10 character field that you were storing on a drive of that size and you filled it up, those 10 characters, and then you printed out all that you could fit in that drive, that would circle the earth about 400 times. So that's what we're talking about with 122 terabytes and a little deck of cards, which just is mind blowing.
That's a great analogy. Yeah, we've been having fun with some analogies, but
It's just
I
hard to
hadn't heard
imagine you
that
can
one.
stuff that much in there. So, what inspired your team to take on such a huge project?
Thanks, Chris. It's a great question, and it's great to be with you. The simple answer is what we kept hearing from customers. Higher and higher density in a single device has become a real priority for folks that are focused on AI model development and deployment. And the really basic reason for that is, all else being equal, the more data you can smash into a single device, the fewer of those you need to
Right.
power, and the fewer of those you need rack space for, and
Yep.
your cooling requirements are reduced, and it has these sort of other consequences that play out across the data center. But anybody who's been following AI this year, been attending some of these conferences, or been involved with making infrastructure choices for AI, has no doubt come up against some of the really scary forecasts for AI power consumption going into the
Yeah.
future. Right. I think earlier this year, the CEO of ARM said he expects by 2030 AI data centers will consume more power than the most populous country on the earth, India, which
Right.
is wild to contemplate. Just a
Wow.
couple weeks ago, the AWS CEO said, within a couple of generations, training a large language model will take as much energy as a large city.
Wow.
And so there's, of course, the question of, do you have capable hardware, and do you have the compute horsepower that you need to train increasingly sophisticated models? But a real top line consideration that goes hand in hand with that is, how much energy are these AI clusters consuming? And we're
Right.
moving from a world just a few years ago where a typical data center rack might have consumed 5 kilowatts of power. And now that, there are designs in the hundreds of kilowatts, there's talk of a
Wow.
megawatt, rack. And it's really, it's difficult to fathom how quickly these power numbers are growing within kind of the AI boom. And so we're hearing from customers, hey, an easy button, one way to reduce that power consumption is use fewer storage devices. And so that's really driven the development of a device like the 122 terabyte one we just announced in November. Is when you're looking at some of these data sets that might be petabytes or tens of petabytes in size, having dense storage can have a significant impact in terms of the overall power consumption of the AI cluster.
Right. So you're saying it's just the inevitable market demand of more data, more analysis of that data. There's no end in sight. And what you're seeing are these real constraints of power availability, space, just these are what's limiting that growth. If we switch to the software side, George, a question for you. On the software side at Ocient, how much do innovations like this play into the way that you design your systems? Do breakthroughs like Solidim's solid state drives impact how you approach the high level design and how software works?
Oh, definitely it does. One of the hallmarks of Ocient's design and architecture internally is the fact that while it is a software solution, it is a very hardware-aware software solution. Uh, One of the things that we realized very early on, especially when it came to leveraging the comparatively extreme capabilities of NVMe SSDs, compared to the more traditional spinning disks, and as well as high core count CPUs, all that good stuff. But we'll keep talking about storage here. Is that you have to interact with them in the way that's optimal for them to achieve a lot of those benefits. And those benefits can be throughput and performance driven in many cases, but that can also be energy and efficiency driven as well. And so, to a very large extent, our ability to stay on top of, be tightly coupled with, and aware of the advancements that vendors like Solidigm are making in their, in their products that we then consume. We're able to leverage and use that to deliver now then our abilities to analyze these really large scale, always on and compute intensive workloads, leveraging them.
Yeah. So Ace, back to you. Solidigm has been making waves in the AI space lately. As you mentioned, there's just so much happening with AI, and it's not at all a static innovation. It's evolving before our eyes. How do these new capabilities? How does this new product fit into your broader vision for enhancing advanced AI capabilities?
Yeah, it's a great question, and it does move so incredibly fast. I mean, it's gotten to the point where if I see you know a research report or a data point hits my inbox and it's older than about 2 weeks old, I think, oh, that's probably irrelevant
Old news. Yeah.
by now, because it's just moving so quickly. And it's difficult, from the perspective of a hardware vendor, and we build a new product, it can take a couple of years.
Right.
It's not a fast process. And so um, being able to skate to where the puck is going to be, to quote the great one, Wayne Gretzky, right, is it doesn't happen automatically. It takes a lot of great work on the parts of our planners and our account teams and stuff to understand, what is AI going to look like in 2026 and 2027. We better get started on that now.
Yeah.
But I don't see, to your earlier comment, I don't see this demand for ever increasing amounts of data abating anytime in the
Oh
near
yeah.
future.
Yep.
That's going to continue to be a need for some of these folks, especially developing these frontier models that are really data intensive, and that then kind of get shared across the ecosystem and fine tuned for all sorts of different use cases. That's going to continue to excuse me, that's going to continue to drive demand for the high capacity stuff.
For sure.
The other side of the sort of the storage story is performance, right? And how do you make sure that you're optimizing and you're making smart choices? A lot of times, what we hear folks are doing, they're not thinking about storage much at all, right? The focus tends to be on the GPU, and rightly so, because it's expensive and power hungry. But they'll ask a question like, well, what's the most sort of terabytes per dollar I can get, and they'll just cram a bunch of that in. And
Right.
we've seen that lead to a lot of suboptimal outcomes. If you're pairing, for example, within the GPU servers, there's usually like 8 slots in the box there where you can direct attach some storage to the GPUs. And if you're putting slow storage in there, you've laid out a lot of cache for high powered GPUs, and they're probably starving for data, right? They're
Yeah.
probably severely underutilized if you're not making smart choices in the on the direct attach side as well, where your capacity requirements are somewhat less, but the performance matters a lot more, right? And
Right.
so it's really about offering a robust kind of portfolio of devices. It starts with a deep understanding of how AI work is done. Where does data live within an AI cluster, right? And then how can we help folks understand, whether they're trying to optimize for time to market, or TCO, or energy efficiency, or whatever the goals might be, making the right choices to help kind of optimize for specific goals is the name of the game.
And not only is that AI technology constantly evolving, the data itself is constantly evolving, and particularly in its growth. At Ocient, we make a platform for the largest scale of data analytics solutions. And there is not a single customer that we have or we've talked to where the data they're analyzing is static. It's always ever flowing in at a increasing rate, just more and more and more data to analyze. That's a challenge. That, in the other challenge, not just the volume, but just the fact that the data never starts in an analyzable form. Um, and so, a question for you, George, is on that data preparation and transformation, especially when it comes to scaling AI or geospatial data or analytics data, the kinds of data sets people are analyzing at scale. How are you approaching this at Ocient to help customers prepare these massive data sets so they can be analyzed?
That's a good question, and I would even just add on to what you said about the ever growing data. 100% true. Yes, it's all we see everywhere and talk about all the time. It's pretty much just a given at this point. But it's also the case that we encounter quite a few customers who are actively have the data available now and are currently throwing it out for lack of a place to put it or lack of
Yeah.
ability to analyze it, simply because the storage capacity wasn't there, the compute capacity wasn't there, the overall ability to work with data at that volume just wasn't there previously. They want to use that data for something, and they think that there's a business value to it, but they can only sample 0.1%, and
Yep.
anything that can enable them to move up to 1% or 2% or 5%, or the holy grail of 100% potentially, is something they're always interested in doing. So when it comes to data prep, right, and just the data flowing in from a variety of feeds and sources and types and formats and all that, it's a huge engineering problem, and technical challenge to just process data at these sorts of
Yeah.
scales.
A trillion things a day or some crazy thing like that.
Or even like an hour, right? Or because those time dump domains just keep coming down, and the
Hmm.
zeros keep getting added on as we move along here, and coordinating all of that across systems in a fault tolerant way. It's one thing to just store it on a hard drive. It's another thing to make it actionable and reliable so that someone can make business decisions based on it. That data has to be good data if someone's going to use it. So you can't feed it into an ML model if you don't know the quality of the data, if it's missing things, if it's got gaps. So you have to be able to quantify all of that and be able to do that at these extreme scales in an effective way that really makes it a substantial technical challenge, which again, is one of the reasons that Ocient is so focused on that hardware aligned, design and engineering. Because it's only really by cutting through all the abstractions and dealing with these devices kind of in their most optimal format that a lot of these things even become possible.
And at a minimum, you have to ingest data and get it in an analyzable state, at least as fast as it's being created. And we're seeing more and more customers just struggling to get the data to where you can analyze it as fast as the new data is being created. Because if you don't, you never catch up. You just fall further behind.
Mhm.
Both of you work at the cutting edge of hardware and software. I mean, it's pretty interesting to hear about that. And I'd love to hear your advice. Maybe doing this kind of peanut butter to jelly. So Ace, what's one tip as kind of a hardware focused company that you would share with software developers who want to optimize for cutting edge storage technology?
I think it's super important to think about the memory hierarchy and how you're using these different tiers, right? And folks, who have spent any time in this space probably have seen a chart or an image that looks like a triangle, right? And you sort of have super high performance, really a small amount of memory at the top of the pyramid, which is kind of your memory that's directly on your GPU or attached to your CPU. And then you've got DRAM, and then you've got flash and maybe mechanical hard drives under that, sort of growing out. And that's an area as we look toward a future where hardware software co-design for AI is really going to be the key to unlocking some of these optimal solutions. Um, Being able to understand that and be deliberate about how data flows through those tiers is going to become super important. Of course,
Right.
we'd put everything in HBM if we could, right? But
Hmm.
HBM is like over $100 a gigabyte.
Right.
Fast flash memory is like 10 cents a gigabyte, right? And so there are
Right.
some significant like efficiencies to be gained and TCO dialing that can be done, right? If you understand those tiers and how to use them and how the data kind of flows through them, to really get specific and intentional about offering the best kind of hardware software solution for your use case.
Right. All right, so let's go jelly to peanut butter. George, on the flip side, what advice would you give hardware manufacturers looking to build solutions that truly empower custom leading, or not custom, but leading edge software?
Yeah, I think a lot of times software folks are, at the beck and whim of the hardware folks. This is the hardware that we rely on in order to do what we're able to do. Uh, a lot of what we've already done is very much we've talked about it today and elsewhere about it's just simply taking advantage of what drive vendors like Solid have done when they've made these drives and put these capabilities in place, standardize on NVMe and that kind of thing. But we one of the things I think is important moving forward, especially when we talk about large scale distributed systems, is that when we optimize what our execution engine does, when we're running queries, when we're deciding where data placement is, or things that are not confined to an individual machine, uh, what that means is that local information on an individual machine is usually not enough to perform the sort of optimization that you like to be doing, whatever that might be in that context, right? I'll use the example of energy efficiency. So one of the things that we're really interested in doing is optimizing, understanding how to manage the energy cost of executing a particular query. There's a variety of ways you could talk about doing that, and that's a whole interesting topic in and of itself. But the fact that a given query for us is running across lots of different computers, each one of those computers has dozens of drives in it, all making localized decisions and so on and so forth. What that means is that truly optimizing and understanding what that energy usage is going to look like is a much larger problem than an individual drive or even an individual node, right? So the piece of example, advice I would potentially give to hardware vendors would be anything that would enable software to inform the hardware about global decisions it might be making in pursuit of energy efficiency or IO efficiency
Right.
or whatever it might be at that point in time. And that's obviously going to be a very specific use case type thing. But that tight coupling that would enable something that has more global information to feed into the devices, whether it be for any of these things that we're trying to optimize, pathways that allow us to do that more efficiently or even at all, as well as the observability of those effects. Like when we ask the drive to use less power, what are we actually getting, right? So that we can measure that, analyze it, and understand how that's actually working across everything to achieve these larger scale goals would obviously be a good thing for, I think, all parties involved.
Right. Yeah. What I'm most excited about is the other 80%. And what I mean by that is when you have a breakthrough innovation like 122 terabyte drive is, most of what will be used in the future are things that are only enabled by the new innovation, the new foundational capability. And so, we're talking a lot about the 20%, the things that people are already doing that just get bigger faster. What's going to be interesting is that what are the other 80% of new uses that are going to be enabled by this technology? 20 years ago, I calculated how many organizations had at least a petabyte under management, and my estimation 20 years ago was 14. And those were the biggest of the big. Ace mentioned earlier that you can get 8 of these drives typically in a single server, a single one-use server. That's a petabyte. So you're talking about a single server that has as much storage capability and a lot more IOPS, because it's a solid state now, it used to be spinning disk, than the largest, computing organizations in the world. What are people going to do with that? What new things are going to be enabled that are going to blow our minds? It's going to be really fun to be a part of in the coming years. But I want to just wrap up today and thank you both so much for joining me. It's a fascinating subject and it'll be interesting to look back on. It's been a very insightful conversation, and I'm sure our listeners have learned a ton about the intersection of hardware and software in the big data space. Until next time, thanks for tuning in to Big Bytes with Ocient.